No, no. I would have had to go home like, shit, I gotta edit this. And then when I edit them, they never upload right. It always just gets weird. So, we have an assignment floating about. I've extended it to Friday already. After talking to several people in here, that seemed like the right move. So that was a good move. I did that before talking to anybody. Let's shoot for Friday. We'll take some time today for sure to work on things. Does anyone have, I've got like one little thing I want to tell you that will help with the assignment and also kind of help us understand some things that are about to happen. But does anyone have a question on that homework?
It's a little bit specific, but for building the Mobius transformations, like it comes up first in problem 5. I think you use it in a lot of problems, but you use like the cross ratio thing.
Yeah.
But the example in the book uses S and T, and they like compose them, but I don't understand why they use S prime.
Yeah, I'm going to show you how. That's my example for today. Like some, so I think I can help you with that, definitely. So it sounds like a good place to start. Yeah, cool. Thank you for. Yay. Cool. Great segue, Ella. Thank you. Money's in the mail. So let's take a look at constructing Mobius transformations. Which I've been abbreviating in my own notes as X forms for transforms, whatever. Could have written transform and not explained it for 5 minutes, and that would have been faster. Constructing Mobius transforms that send 3 distinct points to 3 distinct points. And there's a lot of subtleties to this. I don't like the way the book does it, Ella. So I'm with you on that. I don't think that's maybe the best way to do it. So what we are going to do is first just talk about the cross ratio. You're going to use the cross ratio. So main tool is the cross ratio. Not ration. And after grading them all, I see, I know this quite well, but I'm going to write it a little bit differently here. So I'm going to put Z as just a variable quantity, and then I'm going to have Z1, Z2, and Z3. And I'm going to write out what the cross ratio is for that. Remember, there's like a little semicolon in the middle, and it's like 2 pairs of things like this. And the way to remember this, you've already shown you remembered it for a short period of time for sure, so well done. But the rhythm is this first one, move over 2, so it's Z minus Z2, that's the start. And then this minus the other thing in the pair in the second half. And then move to the Z1 and skip 2 to get that one. So notice how the first one's like this, and then the second one starts like this. And when I say first, I mean the fraction here. So the next one, Z1 minus Z3, and then Z1 minus the other thing. So let's just take a look at what this is doing. If I view this as a transform, so let's say T of Z equals this. So I'm leaving this Z as a variable. And we're going to treat this thing as a Mobius transform. In fact, right, this is a Mobius transform. And remember, they look like this. That's a Mobius transform where we make sure to have that condition held true. But this is just a constant. So it's going to affect the top here, or you can think of it as multiplying across and affecting the top and bottom. And then here, A is 1 on the top and the bottom in this one here. So it's just a Mobius transformation if we think of it this way. I'm in remarkably good spirits today. I don't know why. but I am. So let's think about some interesting points here. If I treat this as a transformation T of Z, what is T of Z3? Remember, the points are all distinct, so it can't be equal to Z2. Z3 can't equal Z2. I'm assuming it's not. What does that give me? Infinity. Because I get division by 0. You see that? When I plug in Z3, I get Z3 minus Z2 over 0. And we've defined this, a non-zero over a 0 is infinity for us in the extended complex plane. So that's infinity. Let's grab a couple others. T of Z2. Can somebody else help me with that one? Nathan, what do you think that is, my friend?
0.
Yeah, beautiful. Nicely done. Cool. And then we've got this other point. T of Z1. Take a moment. What is T of Z1 equal? And it's something lovely. That's right. Let me help. I'll write it out so you can see it. I think I just heard someone get it. I heard a snap in the cosmic fiber of the mind. What is that? 1. So we can think of this cross ratio with that first one left as a variable as a Mobius transformation that sends Z3 to infinity, Z2 to 0, and Z1 to 1. And that's the heart of creating ones that do anything we want. So what we're going to do, here's the game we're going to do. If I want to send Z1 to W1, Z2 to W2, and Z3 to W3, I'm going to create 2 of these things. I'm going to create one that does this. It takes Z1 and sends it to, where did Z1? To 1. It's going to take Z2 and send it to 0, and Z3 and send it to infinity. And then I'm going to create another one that sends W1 to 1. And I'm definitely writing these backwards on purpose. W2 to 0 and W3 to infinity. So I'm going to create this one. I'm going to create this one, just using that formula right over there. I'm just literally going to use this formula to do that. And notice how these sync up. So what I'm going to do is this is going to be some S that moves this way. This is going to be some T that moves this way. I'm going to, and here Ella, this is why they do what they do in the book. I'm going to take T composed with S inverse. So first I'm going to feed things through T and get this stuff out. And then I'm going to take this stuff and run it through the inverse of this and go in this opposite direction and get out W1, W2, W3. So S inverse, so if that doesn't quite make sense, S inverse is a function that goes the opposite direction on these. And then I'm going to compose them. In the book, they do this horrible algebraic thing that I think just sucks. What we're going to do is use the beautiful formula for the inverse of a Mobius transformation. We're going to create this using that formula. We're going to use the inverse formula, which is pretty sweet, and then just compose the 2 things together. And it's so much faster than what they do. So that's the theory behind what we're going to do. Is this sounding okay? Yeah, let's do it. Let's do it. So let's make a transformation. So create a Mobius transform. Oh my God. That sends. Let's somebody give me some good stuff to do. Where do we want to send I? Somebody give me a place to send I. Don't get too ugly. Don't say like 300, plus I or something like that.
2.
Lovely. Thank you. That's the kind of shit I'm looking for. And then we're going to send, how about we just send 1 somewhere? Where should we send 1?
3. Well,
3's good. Yeah, I like 3. What? Oh, or did you have a different thing in mind?
3I.
Ooh. Yeah. Sexy. And then, so I don't know, somebody give me another mapping. I need 3. Somebody give me from to. Somebody give me from. Kitra, where, what's going to be the from?
Let's go from -2.
Tara, where are we going?
Can we go to 0?
Yes, we can, man. Sounds good. Cool. Looks weird. So we're looking for the transformation that does this. So the first thing I do is create the transformation that sends this to 1, this to 0, and this to -2. So step 1 is find t that sends I to 1, 1 to 0. We could, whatever. We could rearrange these so that maybe the computations work out right. Like, for instance, I could send 1 to 1, just change the order on these. It doesn't matter what order I do this in, as long as it's consistent between this side and this side. And then we're going to send -2 to infinity. And to do that, I've got a formula that tells me how to do this. So this t is going to be, I'm just literally plugging in these numbers there. So let's write it out so that we have it in our notes. It's going to be zi 1 minus 2. It's that cross ratio. And then I go to the formula, which you'll remember after doing this a few times. It's going to be z minus 1 over z minus -2, so plus 2, times I minus -2, so I plus 2, over I minus 1. Cool. That's done. So that guy's done. Now I got to do the one that sends, let's do them, let's kind of do them together. Over here 2, I'm going to find S that sends, I'm going to take these 3 points and do the same thing with them. So I want 2 to go to 1, I want 3i to go to 0, and I want 0 to go to infinity. Can you write that out? Could you just take a second and do that? I know you can watch me do it, but let's just do it. Build some stuff.
Is it supposed to be 1 or 2?
Did I
C2?
screw? Oh, thank you. Yes. Thanks, Morgan. Yeah, good call. Glad you caught that now. Good stuff.
That would also change it in the equation.
What's that?
That would also change it in the equation.
Oh, thanks. Extra good tip. Good now. Thanks. Cool. Cool. All right. So, this thing, I don't like this number here. Let's simplify that a little bit. I'm going to just do a little scratch work here because I want to turn that into just a nice multiple that I can actually, let's leave him now. Let's work with this one, because this is the one we're gonna invert. We're gonna take the inverse of this one here. So what we need, so step 2 is find S inverse of Z. And we're gonna use the formula that AZ plus B over CZ plus D inverse is equal to, does anybody remember that formula? You got it?
Yeah, it's negative dz plus b over cz minus a.
Thank you. Cool. So we got that formula. We're gonna need that. That means we need to make this thing look a little nicer. So let's rewrite them out to find S inverse. So since S of Z equals, and let's just write them out. I'm gonna pull that constant out front. I got 2 over 2 minus twice I. And then times Z minus 3 I over just good old Z. Let's put Z minus 0 so we can identify all the appropriate parts and don't twist our minds up. So let me stop. Tell me if this is looking good, if you understand where we're headed and where we've come from. Since you asked this one, Ella, is this looking good to you, or is there anything you want to chat? Yeah? Okay, awesome. So I want to simplify this number. I guess I actually don't have to. So what we could do is just cross multiply. So that's going to be 2z, and that's actually a little minus 6i. So I'm multiplying the 2 across, and I'm going to multiply this 2 minus 3i across. So I've got 2 minus 3i z minus 0. Not bad. Stop. That is loud. We need to do something loud. We'll have a loud day too. So I look at this and then I identify A is 2, B is negative 6i, C is 2 minus 3i, and D is 0. And I use my beautiful formula up there so that S inverse of Z is equal to, and I'm gonna show you a trick for composing these that is so sweet, just lovely. I can't believe our book didn't show it. So let's see, so the minus D, so it's minus 0Z, right, plus B, so minus 6I, over CZ, so 2 minus 3I Z minus A, so that's minus 2. So check it, I'm not even really thinking, right? I am just following a cookbook, following the formula. Is everybody cool with what's happening? Yeah. Okay. So this Z goes away. That'll be nice, right? That's just actually that. But I'm gonna leave it there because I want to show you how to do the composition. So that's S inverse. Now all I need to do is take so step 3. Did I even have a step 2?
I think you had 2 steps actually.
Yeah. So this is step 2, part 3. Let's see. Okay, so this is step 2. This step 3. Oh, that should be 3. Thank you. Okay, so that's step 3. Good. That's 3. 3 continued. Step 4. Compose this shit. Step 4. Find S inverse composed with T of Z. Here's a fun fact about Mobius transformation compositions. I need to kind of erase a little bit here, if that's okay. I think hopefully someone's got that written down. But if I have a Mobius transformation, AZ plus B and CZ plus D, and that's T of Z. And then I have another one, I'll just call it Q of Z, and that is EZ plus F over GZ plus H. And I want to compose these. I can think of them as matrices. So this is really cool, and this works just beautifully. So think about turning this into a matrix, and this into a matrix, just without the z's, like that. Multiply those matrices together, just using standard matrix multiplication, row dotted with column, row dotted with column. So let's do that. So matrix mult right here, and right, that's a dot product, so it's that vector AB dotted with EG, so it's AE plus BG, AF plus BH, and not right. Don't remember this formula, just remember the rhythm. Row dotted with column gets you the corresponding row and column. So C dot E, C times E, plus DJ, DG, and then lastly CF plus DH. And then come back, turn this back into a transform. So the resulting transform is AE plus BGZ plus AF plus BH over CE plus DGZ plus CF plus DH. And man, does that make life easier. And so that is the composition of these two things. That is T composed with Q of Z. And doing that other ways is possible. What you could do is replace every Z here with this entire expression and then simplify. You'll just get this. But I think that's an easier way to do it. Do it your own way, right? What works for you is the way to do this. Let me stop. Can you tell me if that needs clarification, please? So I'll add a few words here to say this. To compose, rewrite as matrices. Multiply the matrices and then encode back to Mobius transform. That's what we're going to do. So I'm going to take this thing as a matrix, so it's going to be 0, get out. This thing here is 0, negative 6i, 2 minus 3i, negative 2. And I'm going to compose that with the other critter we created. Let's make this critter look better. I'm going to cross multiply, so S is going to be 2z minus 6i over 2 minus 3i z minus 0. You see what I'm doing there? Just multiplying straight across. This row times that row times
Why
that.
are you doing it with S again?
Did I already, oh,
You erased
did I already got S? Okay,
Yeah.
thank you. Yeah, where's my other one? I think I lost him.
You erased it.
I erased it, shit. Wrong thing. Can you help me out here? I want T, please. What was T?
Z minus 1 over Z plus 2 times I plus 2 over I minus 1.
Thank you so much. I plus 1, like that?
Minus 1.
Minus 1, thank you. Cool, so that is equal to I plus 2. No wonder everybody was looking at me so weird. Completely different reasons than normal. And then this is I minus 1z plus 2i minus 2. Does that look better? And then I'm going to convert that into a matrix. Slap it onto the right side of this one. So that's gonna be I plus 2 minus I minus 2. I would distribute that minus. I minus 1, 2I minus 2. And then matrix multiplication time. And even though this looks like this is a lot of work, you can ask Ella if this is worse than the god awful shit they do in the book. And I think it's not. And I think it actually makes sense as opposed to what they do in the book. The algebra, you'll have to, you do it your own way. Do it as you see fit. But I have found this to be easier. So now let's all just do this together and then compare notes. And then see if we agree on our final answer. And scratch word might be empty. Oh God. Bless you.
Thank you.
If anybody sees a different number, say something, because I could totally be wrong on my arithmetic. Well, we'll see. It's ghastly, no matter what. Are we matching up on anything? Is that why you're nodding?
No, I was
Oh, just
getting the T stuff.
cool. Okay, cool.
The only thing that
Let's take a look. I could have easily just messed this up.
for the CF plus DH, this is
Okay.
the CF, and this is the DH. Okay, at least I have a negative.
Oh,
so that
yeah, I was
makes it-
worried about that. So yeah, let me go take a look again.
I could be wrong.
Yeah, I mean-
Sure.
So which this is that? That's that guy. So let's see. That was the 2 minus 3I times I plus.
Oh, it's plus 2. That was minus 2.
It's negative I. Yeah. Oh no, it's right. This is right. What you have here is right. Negative I. Oh, wait. So it's 2 minus.
Oh yeah, you have plus 2 in
Yeah.
your work, but it's minus 2.
There we go. There we go. So I did screw it up. Okay, so. Is this okay here, Ella? Or was this like this part's over? Yeah. It's
Yeah,
when
it's just over, where you were just pointing.
that
at your
times
left.
that is what I'm screwing up.
Yeah, because yours has I plus 2 over there, but it's I minus 2, right? Or am I looking at the wrong thing?
Let's see. So that one up there, that one up there is this times this, and that is what you're looking at.
Yeah, CF, and you have for your F I plus 2 when it's negative I minus 2? Or am I confusing myself?
Let's see, so I took that times that. So I think that's okay up there. It is 2 minus 3i times negative I minus 2. And then negative 2 times 2i minus 2. But let me double check that up there. Has anybody gotten anything remotely?
I got something different.
You got something different?
Yeah.
Where, everywhere?
The whole
Please.
bottom row.
The whole bottom row. Okay,
Yeah.
let me redo my bottom row and get a sanity check. So this dotted with that, let's
Yeah.
see, so that computation is here, okay?
Yeah.
So, right, so far I wrote it down correctly, and then I tried to do it in my head, and that's probably what screwed things up. So let me slow down. So let me just FOIL. 2i plus 4 plus 3, because I get an I squared on the inner, and I had a negative, and then the L is negative 6i, and then I've got minus 2i plus 2. So yeah, definitely these cancel, and then we've got 9. Is that what you got, 9?
I got 9 minus 6i.
Yeah, that's what I'm getting now too. Is that what you were getting, Ella?
I was only doing the last one. to be
Okay,
honest.
cool, okay. So I got that 9 right, but that's minus 6i there. Is that what you're getting, Lou?
That's what I got.
Okay,
yeah.
that is right,
Okay.
provided all this was right. Now let's check my second one.
That one, I just got 3.
I got negative
I
3.
got negative 3.
And that's what, this is the one you were asking me about, Ella. Okay, so let's do that together, that's cool. All right, so we're gonna take that dotted with that. So 2 minus 3i times negative I minus 2 minus 2 times 2i minus 2. Yeah? And so then, okay, FOIL, just FOIL, buddy. First, outer, inner. Oh wait, so the inner is gonna be negative 3, because you get positive 3i squared. And then the L is plus 6i. And then we've got minus 4i plus 4. So I think that looks, yeah, look at that shit. Dead, 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 minus 3. Fun, that's cool. We're working hard today. Oh, we got plenty. Okay, God, I was like, how long have we been here? Not as long as I first thought. Cool. Anybody else getting this? Getting so yeah, okay. And this is like democracy, and I'll take the most majority of nods, yes. That's our transform. It just needs to be converted back into a transform. So easy enough. We just encode that into our final transform. So our answer is going to be 6 plus 6iz plus 12 plus 12i, that's our constant, over 9 minus 6i in parentheses z minus 3. Good God. You don't guess that. It was like not even close to obvious. But that's how I do that problem, Ella. I recommend this route. Yeah.
Yeah, I guess what was confusing about the book is that they say they're doing the inverse of S, and then it just doesn't show that at all.
What they do in the book is this, Ella. They take they set T of Z equal to S of Z, and then they solve for Z. And then and so essentially move the S inverse to this side in that way.
Okay.
My way's better. Even though that's a lot. It's just patience, right? It's just like, just calm down, breathe easy, do it. You'll get it. Whew.
There's only words for 3 points though?
Yes.
Okay.
Yeah. So are you thinking about that other problem?
Yeah.
Yeah. So there's a problem. Let's talk about that. So you have some space. So there's a problem that Christian is referencing, and it is, the book opened. I've been on this page so much it just kind of popped open to it. It's problem 12. 3.4.12. So in 3.4.12, and 3.4.12, they say we've got this transformation that sends 1 to 3, I to 4, negative 1 to 2 plus I, and negative I to 4 plus I. When they're asking us, can we create a Mobius transformation that does this? And the trick to this one is, first off, we know, as Christian, as you asked, you're like, can you do it with 4? And you can, as long as they're consistent. You don't need 4 though. You can do it with 3. So how do we answer this question? Well, the answer, let me point you to a result, maybe somebody can tell me the idea, is result theorem 3.4.5. So you would invoke theorem 3.4.5. Theorem 3.4.5 says Mobius transformations take clines to clines. So if these lie on a cline, and they do, because they're just the cardinal points, 1, I, minus 1, they live on the unit circle. Do these also live on a cline? And you can plot them out, and it's going to look weird. You're going to say to yourself, they don't look like they live on a cline. How do we determine if they do live on a cline? What is the tool for taking 4 points and determining, do they live on the same cline? Cross ratio. If the cross ratio is real, you did that on your quiz, right? So take this cross ratio of these, show, you can just say these live on the unit circle. It's pretty obvious. Find the cross ratio of these, and if it's real, they live on the same cline. You don't even need to know what the cline is. If it's not real, they don't. And so it would be impossible to do that then. Does that make sense? Yeah. Good question, Christian. Great question. I got more stuff. Let's take the next half hour and just kind of work on homework. Let's take this time together and work. I'm gonna run to the restroom, remove all the soot from my hands. I'll be right back. acceleration.
We should talk at some point. I would love to talk to you, of course. Yes, because I'm probably gonna be here, but sounds great.
Is it okay? Good. I'm glad. Yeah, no pressure. Just gonna do. I'm going to do it.
I'm just gonna do it.
I'm just gonna do it. No, I talked to Pat about this. I was like, can I be Christian's advisor?
Yeah,
He's like, I was planning on it. So
stop it.
yeah, solid. We'll figure it out. Of course. Yeah. Oh, that's an interesting question. Okay, so there's one thing you have to check. Great question. Kitcher's asking about question 3, which says, prove that the composition of two Mobius transformations is again a Mobius transformation. And you can use this thing we talked about to get the composition, but you still need to verify one thing, and that is that this times this minus this times this is not 0. So that's the only thing you'll really need to check. Does that make sense?
Yes.
Okay, cool. And that actually looks pretty fun. I'm gonna do that now.
What did you say? Sorry.
It's okay, it's okay. Question
Yeah, 3.
3, thanks. They ask you to show that the composition of two Mobius transformations is again a Mobius transformation. And Kitcher asked, can we use this to find the composition? And you absolutely can. You'll just need to verify that this times this minus that times that is non-zero.
Okay.
That's it. Yeah, we're good.
Would you have to do it that way, or what?
No, not at all. What were you doing?
I was basically just gonna reason that, like, if Mobius transformation is the composition of an even
Ooh,
one
that's-
Mobius transformation composed with another is just like an even.
brother, that's awesome.
Sweet.
Damn. Oh, can I share that?
Totally, yeah.
That's a great proof.
I didn't hear it.
Yeah. Hey, you want to hear a great proof for that question? Christian came up with a great, but it's so much more elegant and beautiful. Could you please tell us that, friend?
Sure. So, any Mobius transformation is just an even number of reflections. So you could just reason that if you're composing one Mobius transformation with another, if it's just like a sequence of even reflections, and then another sequence of even reflections, which should be another sequence of even reflections, because even numbers are closed under addition.
Damn. You gotta write it up. Boy, is that beautiful. That's so much better than that garbage. I'm still gonna do that garbage because I'm very curious about it, but I like your proof way better. That's a mathematician's proof. You don't want to do what I suggested, Kitra.
No.
No, it's pretty hideous, I think. I'll do it. I'll take the bite. Take the hit for all of us. I mean, do as you see fit, of course, my friends.
That's great.
I don't know, it depends on what you like, you know? And then show that that's non-zero.
You just have to FOIL it all out.
Something, yeah, and then you have to use the fact that AD minus BC isn't 0, and that EH minus FG isn't 0. So somehow you'll have to find those quantities in there.
That would be
It does sound kind of cool. I mean, you know, yeah. It kind of depends on the way you like to approach things.
Mm-hmm.
Yeah.
I think I'm gonna go for it.
Oh yeah, good, cool. Me too. I'm gonna go for it too. Oh, it's pretty cool. It's better than you think. Huh. Works out pretty nice. It's not bad. Yeah, worth your time. Yay. Hi.
So on the part where you multiply across, you can get like
Mhm.
ABCD.
That looks good.
This just is a 3.
Mm-hmm.
So I don't get how to multiply across.
Let's just make it a 3, and it'll be 3z minus 3i.
Okay.
Yeah. Oh wait, how did it?
Because I
Oh
just,
yeah, I see.
I'm not,
Yeah, see,
Which
the,
one?
the reason you kept this one separate is because these two don't mix, because they're
Mhm.
they're like oil and water. But these are both just real, so you can combine them into a 3. And so it will just be 3z minus 3i.
so is that just, I guess like,
Yeah, what's confusing you here?
what I'm confused about is if it is 3z minus 3i. I know this is C, this is D.
Mm-hmm.
What is in D?
A is 3, and b is negative 3i.
Oh,
Yeah.
okay.
Yeah.
I just wasn't seeing.
No, that
it, I
makes
guess.
sense. Does that
Okay.
mean you see it now?
Yeah,
Good,
Yeah.
good job.
that was it.
Okay, cool.
Yes, sir. So for compositions, say, I know the T composition.
Mhm.
Right, so let's just, we have split TB, two of something, yes, or 3 of X whatever plus 3, right? And the composition would be 3 and then plus S.
Yeah,
right?
exactly.
Mhm.
But this accomplishes the same, so it's gonna show you
It's the
real
same
quick.
thing, okay.
Yeah, so, so like, let's say we've got AZ plus B over CZ plus D, and, that's T. And then S equals,
Something else.
yeah, EF plus G over H, EZ plus F, wow, I'm pressing, thank you, yeah, I need like something a little hardier. EZ plus F over GZ plus H.
Okay.
So if I'm gonna do S, or T composed, yeah, whatever, right,
Right.
yeah, of Z, then I'm gonna plug this expression in for Z, so it's gonna be A, EZ plus F over GZ plus H, you know, blah, 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 you know, the same thing you're saying.
Right.
When I simplify this out, Nathan, I'm actually gonna get the same thing I would get
Okay.
that way.
That makes sense.
Does that make sense?
Yeah.
Yeah, yeah, cool.
Again,
You're welcome.
I submit that problem that way.
You can do it however you want, yeah. If this makes more sense to you, do what makes sense.
do better.
Oh, okay,
They make more sense, yeah.
okay, cool.
Thanks.
You're welcome. You're working on schedule, working on it. Okay, yeah, that's cool, that's cool. Do you need help with that, or are you good?
Well, I was gonna ask
Mm-hmm.
if we could meet like on Wednesday,
Yeah,
like I can email you.
yeah, just come on by.
Okay.
Sounds great.
Yeah.
It's been a while.
Yeah. I think, I mean, maybe we'll talk about it more.
Mm-hmm.
History and foundation and math is not too.
It's a weird class. Has anybody in here taken history of math?
Yeah.
What did you think of it?
Awesome.
Awesome,
Oh, really?
cool.
Yeah.
Who'd you have it with?
Pat
It's in cyber.
Yes.
He'll do a great job too. Did anybody have it with Cybert? Because he runs it really differently. You'll do, I think you, with him, the students do a lot of presentation of the material. But I wouldn't shy away from it, you know, it's chill stuff.
Yeah, that's what I figured.
Yeah. Although shockingly, some of that old stuff is really hard.
Yeah.
You know, it's weird the way they do things. Yeah.
But yeah, I didn't
Okay. Cool. You have to take that? Yeah, you do have to take it, yeah. That's okay, stop by. Happy to help. You know.
Okay.
Yeah, is that all for now?
Yeah.
Okay, cool. Hi, you good?
I don't know, I
Is it working okay for you?
after algebra and math stats, so I did yeah, so I don't know if I haven't done it.
Yeah, fair enough.
Junior year.
Okay.
Is it supposed to be freshman year?
Yeah.
History math.
It didn't work?
I'm not going.
It depends.
Do you want me to help?
Student because
It's okay.
I think
It's
for
okay.
history and math,
I tried to do this.
Yeah.
I did
I just
at
do
the
it.
same time.
Oh, so you were trying to work this example through, or is this one from the problem?
No, the one where
Okay, gotcha.
at least when I took it with Pat. So it was like I'm also really slow reader. So like
Did you find the inverse of that one first?
it's
Cause
all
that,
like
that's what happened. Yep, that should happen.
like
But it does make
will
it.
Mhm,
chapter
yeah.
notes.
Totally.
Just like these things.
Yes, ma'am.
I just don't know what you learned in that class. Is it just history?
Good work.
What do you learn?
Yeah, you start from like
Morgan, you
the
got
very
anything you wanna
beginning,
chat about?
mathematics, like in ancient
Oh, number
Egypt.
5 is not just.
Who discovered
is
zero
that
and
what
stuff
we-
like that?
Huh?
Who discovered zero and just
Yes.
like that?
Yeah, like
That's
like
And then is it always
Like,
gonna be 1 0
who was the first to
Uh,
find the area of the
yes.
square and
Yeah,
line
when you
and
use
learn
that,
about,
Oh, well, it
like,
doesn't really matter, 'cause you're just
agriculture.
plugging them in anyway.
It's just personality,
For the
you
most
learn
part,
about like
yeah.
different mathematicians, but you
Okay,
also
good.
have to like
Okay.
practice some of the ways that they used to
A
do
question
it.
for
Yes,
you.
sir.
But
Is
it's not
inversion
that
about a
much.
circle? Is that a Mobius
It's more
transformation?
literature
What
based.
an interesting question.
I would say
Because
it's
if
hard.
it is, then
Okay.
that would be a lot
I don't know, I was
easier for
just
number
like-
14.
So how many
But I didn't wanna,
inversions
I didn't know if 3.
does inversion
Also, if you
involve?
take it into
I have no idea, because I would assume one.
Thank you.
There you go.
I like cyber too.
No, it's not, that's right.
Abstract.
Because it's got a conjugate, right? Inversion around circles, 1 over z conjugate, and we can't do that with the Mobius transformation.
I got that class last
How
year.
did I do 14? Like, how did I, because I was looking at this.
Oh, see, what?
Yeah.
Can I see what it was?
Total.
I had it for linear algebra.
Oh, pick
I
3
was like, I
points
didn't
on the
read
Just
it.
circle.
on the circle.
Yeah, and then, and pick 3 points here.
Just like,
Any 3, and it'll work, cause this is a climb, and that's a climb.
they can be like any three, like, they don't have to.
Any 3, so pick you pick sweet ones to work with.
Yeah, if I can get through
Does that sound right?
Yeah.
Yeah, and then just use our method.
Alright, that, I'm gonna do that.
Cool.
Sweet, thank you.
You're welcome. You doing good?
I think so. It's getting kind of ugly. So
Yeah.
And
still,
it was
but
fine,
I'm done
so-
with that.
Okay, cool.
Yeah, oh lord.
It's just a lot of.
Yes, it is. Yes, it is. I can give you some hints whenever you're ready. How you doing?
Still doing good.
Still doing good?
Yeah.
Awesome. How you doing?
Me too.
Good.
Just the
Doing good?
negatives and.
Okay. Sweet. Which one was this? Oh, cool. Which route are you gonna go?
The one. I'm going to go with the matrix. Not sure.
It's not that bad. I think Kitra's over there wading through the muck. I can give you a little hint if you'd like.
Yeah.
Yeah. So when you might want this hint too, Kitra, to help, kind of like a guiding light. When you do, so you want to show that the negative of that times that plus the product of those two is not 0. So that's our goal to do if we're going to take this algebraic route. You are going. The only facts you're going to be able to use are that AD minus BC is not 0, and EH minus FG is not 0. That's really the only 2 things you'll know. So when you do these two, first off, a bunch of stuff is going to cancel, and it's going to be really nice and satisfying. You're going to see a bunch of stuff cancel, and then you'll be left with, I think, 4 terms. Blah plus blah plus blah plus blah. Look for these things in there. Cecil, you doing okay? Got anything you need help with? Cool. What can I do for you? Ooh, let's see, I gotta remind myself what the problem was. Or do you have it written down?
But I started number
Oh,
2
just find
down,
the fixed
but yeah,
points.
it's fixed.
Oh, this one here, find the, is this the one? I'm sorry, which, oh, this one, 13, okay.
Yeah, I just started that one.
No. Let me double check. Let's take a look, but I think, yeah, I think that's all you need.
But we asked for transformation.
So,
Yeah.
this one here, right? Yeah, just, yes ma'am. And one of these will have infinity as a fixed point. So, did I sign all of them, A, B, and C? Yeah, so one of them will have infinity as a fixed point, and that's the only time you'll have to worry about that.
So I don't even remember how.
But so far you haven't, I don't think you've got to that one yet.
And
I was thinking to do like a translation.
Does that
thing
help?
Like we did early in the semester, relationship transformation. But there's no original equation.
Oh, no, that's okay. This one doesn't have infinity.
yeah,
This
the only
one
thing I can
doesn't,
think of doing is, like,
but
writing it.
it's this one here. Yeah. Because you've got just a constant times z. So if you put infinity in there, I times infinity is still just infinity. Anything times infinity is just infinity again. So this one has
I
infinity.
think so.
And then you've already found the other one.
Was that was explained by 2i by angle?
Ah, cool. Let me give everybody a hint on that one. Cool. Hint on 414. 3414. On 3414, you are asked to find a Mobius transformation that takes, it's a circle of radius 4? or 2? Yeah, so you take the circle of radius 4, and you want to find the transformation that maps that onto the line y equals 3x plus 4, which, you know, whatever, something like that. So what you should do is pick 3 sweet points off of the circle and 3 sweet points off of this, and use the thing that maps 3 to 3. And since each is a cline, it'll work. Does that make sense? Yeah? Cool. So that's what you want to do there, Cecil. Yeah.
Oh, sorry.
That's okay. Yeah, you got to do what you got to do.
Is it, if you get 0 for A and B on one of them, is that like a red flag?
That's a red flag. Yeah.
Okay.
Which one is it? We can talk about it on Wednesday too if you want, if you got to get to work. But let's take a look real quick and see if we can.
For finding S, I think that I minus I. So would have to say 0 and then multiply across.
Well, here's the problem here is these need to be 3 distinct points here, Alice. So I don't know where. You'll see these, no 2 of these can be the same, and that's the problem. So I don't know how they both got to be I.
Did I literally write the problem?
I think that might be, yeah.
I hope that's
And I'm
it.
glad you noticed that that is the problem, because that is their problem, my
Okay.
friend. Yes. Yeah, just check the problem. Thank you. Thank you.